Hello and welcome. I've been asked over a great many years by all sorts of people, I've been asked how your computer works. There's an awful lot of people who can use a computer very competently, but not all of them actually understand exactly what's going on inside, and some of those people would like to know. So last year I wrote a book called All About Your Computer, and I've also been asked to make a video about the book, and this is the video, and I'm going to explain to you a bit about what's in the book, but also how I've gone about explaining how your computer works. So this is the book. It says here, it's an explanation of the computer for the interested user. Good. Okay. Right, well, it's quite a complicated subject, so we obey the principle that you start with what people know and you go on then, after that, to what they don't know. So what most people know about is what they see on their desktop PC. So we've started with that. They see the system unit of their PC, they'll see the monitor, they'll see a keyboard and mouse, they'll see a printer and a scanner. And then what we do is we look at that system unit, starting with the front and the parts to there, and then we turn it round and look at the back, and we see all these different connectors at the back of the computer, and we explain what each of those connectors is and how it works and what it's used for. Now, most people have a pretty kind of good understanding of that, so we're starting with what people know. Then we slightly start to enter what people don't know, because we take the back off the computer or the side, and we look into it, and we can see here some of the things that are inside it. The biggest thing that's in there is the motherboard. So we have a look at the motherboard, and we can see the fan, and then we'll see the central processor on the motherboard, which I'll show you here. You can see here the central processor, and we can see the memory, and we can see different components on the motherboard, and that particular chapter explains something about some of those components and what they do. And everybody, of course, knows when you're talking about a computer, they know about memory, and we talk about computer memory, and we talk about how this computer memory works. So for example, we can see here we've represented these memory cells in the computer by these circles here, and everybody perhaps knows that these memory cells can be switched on or they can be switched off, and we can represent this here, and we've shown these memory cells in groups of 8 because logically that's how we arrange them. Groups of 8, one group of 8 being called a byte. Each one of these memory cells holds what's called a binary digit or bit, which is just a switch on or off, and according to whether we switch those cells on or off, we represent numbers. So for example, if we take that one and we just switch that one on, we can represent the number 1. But if we use them all 8 of them, we can represent any number up to 255. And if we string bytes together into what we call words and double words and so on, we can represent bigger and bigger numbers. But those patterns of switches being on and off not only represent numbers, but that number also is used, it can be interpreted as a letter of the alphabet. As an illustration, that set of binary digits there, that set of bits, actually represents the number 97. That is the number 97. And if it's in a word processing document, that would be interpreted as the letter A, because every letter of the alphabet is given a code in that pattern of binary digits in the byte. And then what we explain here is that this memory can be regarded as being like a ladder of memory. And in that ladder of memory will be the letter that you're writing as you use your computer. And each letter is represented in one of those bytes, as we said. So if we put the word hello into memory, that's the letter H at the bottom there, then E, and then two L's, and then O. So we can represent any words or text or punctuation marks and symbols and so on. We can represent them as the values stored in your memory, in the bytes of your memory. Then after that we go on and we look at the storage, fixed disks. Now of course some people do get confused between memory and fixed disks. Memory holds what you're working on at the time and is usually fairly restricted. The fixed disk holds everything that is in your computer, and when you use something like a word processing program, then that is pulled from the disk and loaded into memory. And when you choose to load up a particular document, like a letter or something you're writing, then that's taken off the disk and put into memory so that you can edit it with the word processing program. Now here shows what the hard disk looks like, because I took the top off and you can see the disk and you can see the read-write head of the hard disk there. So I explain a little bit about hard disks and the problems and the advantages and disadvantages and how they work. And then we look at modern solid state disk technology here, which a lot of people are using in their computers nowadays. Then we go on to optical disks. These start with CDs and then go on to DVDs and Blu-rays, and I explain how those different kinds of disks work. And of course everybody knows that there's writable and rewritable and all that kind of stuff. Well, I explain how they work as well. And we also took a CD drive to pieces. Then we get on to one of the most important parts of your computer, which is the central processing unit. And here's the socket of a central processing unit, and there's the upper protective metallic cover of the CPU, as we call it, CPU. And then underneath it here, you can see all these contacts which have to be made between the central processing unit and the motherboard in the socket. And some of these contacts are made by pins or pads, and some CPUs have many hundreds and in fact even thousands of connections that must be made in the CPU socket. And so they're gold plated in order to ensure that the contact is good between the CPU and its socket. Now, I then go on to a little bit, we get a bit abstract after that, and we talk about how we can manipulate the data inside your computer to make the computer add up, subtract and compare numbers and do that kind of thing. And this is all done in what is known as Boolean algebra. Boolean algebra was created by a chap called George Boole, who happened to be born and worked in the town in England where I was born, that is in Lincoln. Now George Boole created Boolean algebra, which people learn at school nowadays because they learn truth tables, and the idea is that this is how you can model the real world, because you can combine one number with another, and you can doing that combination, you can compare the numbers, you can add them up, and you can make decisions based on whether, for example, two numbers are the same, or whether they're different, or whether one is greater than the other, or the other is greater than the one. And we manipulate all these different binary numbers using these binary operators like and NAND and OR and NOR and all these. And all this is done using a set of transistors. And the transistor, it lies key to the structure of the central processor, because the transistor is being used as a switch. And as I said, there are billions of transistors in your computer, and therefore there are billions of switches. And we build these transistors up into units. Each unit is capable of carrying out one of these types of operations that we've been talking about in Boolean algebra. So for example, we've explained how you can make a pair of transistors act as a gate to perform the AND function, or the NAND, or the OR, or the exclusive OR, etc., etc. And I've drawn a few circuits here to illustrate this, and if you do find yourself reading the book, you can take it or leave it. If you think that you can cope with it, fine. If you don't think you can cope with it, you can leave it for another day and move on to the next chapter, because some of the chapters are quite easy and some of them are just a little bit more taxing. Then we come to the structure and function of the central processing unit itself, and I'm explaining here what it looks like under the microscope. Bear in mind that it may consist of billions of transistors on a little piece of silicon, which itself is no bigger than my little finger nail, and yet that can contain billions of transistors built up in a system of silicon. And this is an illustration of one kind of processor, and it shows you some of the functional blocks. Each one of those functional blocks is hundreds of thousands of transistors. And then this is a kind of slightly easier to understand functional diagram showing you the different blocks within the central processing unit that can do arithmetic operations and logical comparison operations, etc., etc. All that's in there. Then I explained to you how we can use real numbers in the computer. When we talked about the patterns of digits before, they were just integers, but of course real numbers have decimal fractional parts and they have whole number parts, and how do you actually store those numbers so you can manipulate them? And I illustrate this with the number pi, and how do you store the number pi 3.41 in 16 bits, and this is how it's done. You might find that interesting. And then a little bit more here about how you can take these numbers and you can feed them in to these logical units, these gates, which can produce you answers to questions. I do, at the end of this section on the CPU, I do mention the two different design philosophies which have evolved in central processing unit design, which is what we call the complex instruction set and the reduced instruction set computers. Now, complex instruction sets computers are the ones which are present in your desktop PC and your laptop PC, and they get quite warm because they consume quite a lot of electricity, and these are the processors which are mainly made by Intel and AMD, and these are the traditional type of processors. But almost by accident, in the early 1980s, an English company called Acorn Computers actually started to design reduced instruction set computers because Intel missed a trick. Acorn asked Intel to design a processor for them, and Intel weren't interested, so Acorn went and designed one themselves, and they chose the simpler design of the reduced instruction set computer. And this is a very interesting example of how it's impossible to see the future, because they definitely didn't know at that time that their reduced instruction set computer, because it consumed less current and it was simpler to make and it was very small, it would find its way in the future into mobile phones. So your Apple iPhone has got one of these processors in it, and so has your iPad and your camera and your video camera, and all kinds of other devices have these particular processors in, and the company concerned is called ARM, A-R-M, and originally that was called that stood for Acorn RISC Machine. Now it stands for Advanced RISC Machine. But it is interesting, if Intel hadn't missed that trick right back in the 80s, then they would have their processors in your mobile phone and not ARM processors. So there you are. That's an interesting story which is in the book. Then we look at how you make the computer do the things you want it to do, how you write a program. And I start with explaining how each command that you can give to an instruction that you can give to the processor is stored as a set of binary digits, and those binary digits can cause the processor to carry out a particular instruction. And I illustrate that with a piece of code which came from a program which I wrote in the 80s for the Z80 processor, program called Fantastic Voyage, and I illustrate how you can make the computer here compare some numbers and take action according to the result. And this is the representation in memory here of what's going on in that part of a program. But of course this is just a taster, because later on we look at programming your computer in a bit more detail. A little bit of a diversion here, because we look at how the computer is able to start up when you press the on switch, what actually happens to enable it to load the operating system. And then we look at operating systems, spend a chapter looking at those. So we look at MS-DOS, which everybody's heard of, which was around in the very late 1970s, the very early 1980s, and in 1985 Windows came out. I look at Linux as well, but we look at Windows, all the versions of Windows from Windows 3.1, and I still have Windows 1 as a matter of fact, but we look at all those early versions of Windows and other operating systems and how they all compare until we get to Windows Vista, Windows 7 and Windows 8.1. We can't look at Windows 10 because at the time last year when I was writing the book, Windows 10 hadn't actually been released, so we couldn't do that. Then I just explained to you that Windows is not perfect and there are several little issues with it, and I illustrate some of those, because you can't take things for granted. Just because something is very widely used, it doesn't mean it's necessarily perfect. Then we go back to programming a computer, and we have another look at some machine code here, very low level instructions for the computer, and we take that apart and show how it works. Then we look at something called assembly language, which is just a development one step above machine code, and we explain why that came about and what it's used for. And then we look at high level languages like C, and there is an extract here from a small C program, well, it's from a big C program actually. For Windows, it's my personnel management system which I wrote, and it's written in the C language, and it's written for Windows, and it explains to you how it handles what happens when you press a button on the screen. This is the screen, one of the screens from my personnel management system, and this section here tells you what happens when you press one of those buttons, which is quite interesting when people use Microsoft Word and Excel every day and they're clicking on buttons. It might be quite interesting for them to know what the computer's doing when they press each button. Then we even look at programs like BASIC, and we look at database programming, and we look at an example as to how you can query a database using a language called SQL, and that covers the programming chapter. Then we go on to networking, and we look at how you can connect two computers together and have them transfer data to each other, to and from each other, over a wire. And we spend a little time looking at wired networks, which are called Ethernet networks mostly, and then we look at Wi-Fi, wireless networks, and we consider how they work. And all this is a precursor to the next section, which is quite important these days and has been for many years now, the Internet. Notice it's spelled with a capital I because it's a proper noun. We explain how the Internet came about. It was developed in the military in the US in the middle 60s, but it's dependent upon the concept of what is known as packet switching, which was not developed in the US. Actually, packet switching was invented in the National Physical Laboratory here in England. But I have to say that the US military were the first people to use it. So we came up with the idea and they used it. Actually, that happens a lot, doesn't it? I explained to you about how the IP address of your computer enables your computer to be identified on the internet so that the information that's crossing the internet can get to the correct computer. And we look at then the way in which the internet has grown. You might be interested to know that in 1971, for example, there were only 23 computers connected into the internet in 1971. And there were well over 1 billion by 2013. So that's interesting. And we also look at, just show you here, the amount of data which is conveyed over the internet. In 1970, only 5 megabytes was transferred between computers over the internet, whereas in 2012, 34 petabytes were transferred. Now, you know that a byte is 8 bits, a kilobyte is 1024 bits, a megabyte is something over 1,000 kilobytes, a gigabyte is something over 1 million kilobytes, and a terabyte is something over 1 billion kilobytes, and then we've got a petabyte, which is 1,000 billion kilobytes. By Jove, that's a lot of data. Then we look at the World Wide Web. Now, the World Wide Web is not the same as the internet. The World Wide Web uses the internet, but it's just an application of the internet, like email or whatever. The World Wide Web is just an application of the internet. The World Wide Web was created as an idea and implemented by a chap called Tim Berners-Lee, who was working for CERN. Now, you may know that CERN is a particle accelerator which has been constructed between the boundary of France and Switzerland. I've been to CERN, and I've been down and had a look at the Atlas detector. It's a fascinating place to go to. You can't go there now because it's actually in use, and it's got all these particles whizzing around it and colliding and making lots of different new particles as it does so. But Tim Berners-Lee was in the IT department in CERN, and he came up with the idea of the World Wide Web to allow people to exchange proper pages of information. You could do that in a way on the internet before the World Wide Web, but it had to be done in other forms which were not so useful. And we explain here how you can make a request to get a web page from a server. You can sit at your computer, make a request for a web page, and that request will result in that server delivering that page. And then how does your computer interpret that page and put it up on your screen? It's all explained in this book. Then we explain about browsers and search engines and so on. And then we look at internet domains, like top-level domains you've heard of, .com, .org, .net, etc. And country-level domains like .uk, .fr. And we explain why, for example, there were so many more domains registered in UK and in Germany than there were in France. Interesting little story about that you might be interested in. And then we look at the number of websites, the growth of websites. Now, Tim Berners-Lee, it's claimed that Tim Berners-Lee created his first web page, and it worked, first of all, after he'd worked for some time on trying to make everything work, that the first time he got it to work was Christmas Day in 1990. Now, that's the rumour. That means that there was only one website in 1991. But by the year 2013, right, we're getting on for well over 500 million websites, and actually it's difficult to count them for reasons we explain in the book. And the number of web pages would be well over 1 billion. And in fact, again, we can't estimate that. But I have actually given you here an illustration of Tim Berners-Lee's very first World Wide Web page that he produced in 1990. Then I go on and explain a little bit about how the internet is paid for. And as part of that, I explain to you how you connect to the internet and what it costs and what's involved. And we take you through the different stages of development, like dial-up that you may remember, and then broadband and now fibre, and how does all that work, and how you pay for it. And then finally we come to this important section on safe computing, and it's how to look after your PC and how to look after your data. It's how to make sure that your data stays safe and that your PC continues to work, and it covers things like backing up, what to back up, where it is, where is the data that you need to back up, where is it, and how should you back it up. And I explain exactly how you should do that to keep your data safe. And then we have a look at keeping your computer in good nick, carrying out proper updates and so on. And then carrying on with the security theme, we look at passwords, how to create safe passwords, We look at encryption, that is how the data is passes between you and a server somewhere on the internet safely in such a way that people can't read it. And we cover a few bugs which have happened in different aspects of internet usage. And then we also look at malicious software, viruses, worms, Trojans, rootkits. What are they all? How can you avoid them? How can you make sure you don't get your PC infected? What's the risk to you, your data, your money, your identity, and how can you minimize those risks? And what do hackers do? How do they do it? How do they get hold of your data? And then we also look at something which is quite important in connection with bank accounts and so on, which is the process of phishing, which you may have heard of, a way of hackers managing to get access to information, for example, like your bank account, that they shouldn't ever have access to. And by the time you've finished that, you will come to the end of the book. And the very last thing I mention is a little story about something that happened in the National Health Service a little while ago, an interesting little story, and it illustrates again how things can go wrong. Final chapter just says, congratulations, you've completed the book, and happy and safe computing. So that's it. In all this, I haven't told you how you can get the book. Best way of getting the book, the web address will be going across the screen now. You go to http://lulu, that's lulu.com/K.A. Spencer. Many thanks for watching. I hope you enjoyed it. Bye.